suppose we're ready?
I'm sorry?
Are we ready? Good morning. We are going to begin this morning. This is the sixth day in OCC 25875. We are beginning, 8 minutes late. We were evacuated from the building shortly before 9 for a fire marshal visit, a routine fire marshal visit. Let me ask, I believe I recognize everyone in the room, but this is the sixth opportunity for public comment. Sheila, is there anyone on the platform?
I am not seeing any hands raised, and there was nobody signed up.
Okay, let me offer one thing. Sheila had made arrangements for simultaneous interpretation between English and Spanish and English for the public comment opportunity both tomorrow morning, August 4th, and also Friday morning, August 7th. We may finish today, regardless of whether we do finish today. However, we will be on the platform for to invite public comment in the event someone had made plans to offer it in the morning and desired Spanish interpretation. I cannot imagine that we will come anywhere near Friday, so please assume that tomorrow morning will be the last opportunity to offer comment either in English or in Spanish. It looks like we have Saraswati Khalsa on the platform. Can you unmute yourself?
Hello?
Oh, yes. Hello. Would you spell your first and last name, please?
Yes, Saraswati is Saraswati. That's my first name. My last name is Khalsa, Khalsa.
Do you swear or affirm to tell the truth?
Yes, I do.
Thank you. Go ahead.
Good morning. My name is Saraswati Khalsa, and I live in Espanola. You might remember that in November last year, the WQCC voted to rescind its decision to revisit the rule prohibiting discharge of treated produced water because the vote to allow a new hearing had been tainted by the actions of the governor's office. It was revealed by a reporter that the governor's office instructed her agency heads to sit personally on the WQCC and get this over the finish line. And that is what they tried to do until a journalist and the public called them out and the WQCC was forced to backtrack. Now we learn that the governor is again interfering in the regulatory process in service of the oil and gas industry. In an email written on July 8th, 2025, Jennifer Rainey from New Mexico Tech sent an email to two folks at G&K, Dalva Mullenberg and Anthony Trujillo, copied to Justin Wrinkle and Jesse Tremaine of OCC.
Madam Hearing Officer, this is
Yes.
I'm going to interject here and object. She's referring to attorney-client privilege communication. If I am on the email and Dalva Mullenberg is on the email, this is an communication between our contractor and counsel.
Okay.
I have no idea who this is or how she got a hold of this email.
Yeah. Ms. Khalsa, New Mexico does recognize attorney-client privilege. Do you have something else to say?
This was obtained via IPRA, so it's an open government record as far as I know.
From whom did you IPRA it?
It was sent to me by Colin Cox with Center for Biological Diversity, and they obtained it via IPRA.
I will need to see, Madam Hearing Officer, I will need to see the document that they're referring to. There are some documents that have been produced in response to various IPRA requests that do include us. However, speaking to the content of that, the content of an internal email in the form of public comment, I am going to renew my objection that this is veering into technical testimony. However, obviously, I'm unaware of the specific email, that content. The nature of the public comment is concerning.
Yeah. Mr. Chair, do you have an opinion here as to how to proceed?
I'm happy to let Commission Council also weigh in here. Certainly, public comment. I'm not sure what the procedures are here for objecting to public comment, given that it's public comment, and public comment is, I'm not sure that I have an opinion formed at the moment as to how public comment and attorney-client privilege intersects.
Mr. Chandler?
Madam Hearing Officer, Mr. Chair, the representation is this was a public document that was provided. So if that's the representation, that it's public comment can be made on a publicly released document.
All right. Thank you both. Ms. Kulsa, go ahead.
Thank you very much. So the heart of the email, which was obtained via this IPRA, reads, Dahl and TJ, the time has arrived where we require G&K's legal expertise for the Class 6 primacy rulemaking package that New Mexico plans to submit to EPA Region 6. We had planned to submit the draft version of the crosswalk in the rules next week, but there are immediate concerns that these proposed rules will need to be approved and heavily modified by both WQCC and OCC before we arrive at a comprehensive package. And that could set us back up to 6 months or more. Seeing as the governor's office would like to expedite this process as much as possible, we'd like to honor her request to run this through the OCC only, and would welcome any creative solutions from your end that support an approval process that does not also burden the WQCC board. In light of this, OCD is requesting a memo from G&K that describes the proposed rules, incorporates all various CO2 waste streams beyond oil and gas, and why, how, if existing statutes justify the Class 6 program falling under the umbrella of OCD. Are you available today or any other day this week to speak with Jesse and Justin about this? So it appears to me that G&K did find a creative solution so that the WQCC wouldn't be burdened, just as Governor and OCD requested. Much like the produced water debacle, this rulemaking is now tainted by the governor's influence and the naked bias revealed by the efforts of OCD to avoid a review by the Water Quality Control Commission. The public has been betrayed by this administration once again, and our water and health put at risk for the benefit of the oil and gas industry and their pursuit of a false climate solution, carbon capture, that has been proven time and again a dangerous distraction from taking real action to stop the combustion of fossil fuels before the whole world is on fire. This rulemaking too is tainted and must be thrown out. I will submit this comment along with a copy of the email as a written comment as well to the email provided in the notice. Thank you.
Thank you, Ms. Kalsa. Sheila, is there anyone else on the platform who'd like to offer public comment?
I don't see any other hands raised.
All right. Again, there will be one more opportunity, an opportunity supported by an interpreter, tomorrow morning, August 4th at 9 a.m. Let's return then to the technical case. Are there any preliminary matters before we hear Dr. Harvey's testimony? No? All right, let's go to Dr. Harvey.
Thank you, Madam Hearing Officer. Dr. Harvey, can we have you turn on your video? Okay, and we may need just a moment as my co-counsel Rose Rushing is changing her permissions to allow screen sharing as she's going to be running our slides this morning. And Dr. Harvey, we can see you bright and clear. Thank you so much.
You do need to unmute yourself.
Okay, can you hear me now?
Yes, thank you. Would you spell your first and last name, please?
Charles, C-H-A-R-L-E-S, Harvey, H-A-R-V-E-Y.
Do you swear or affirm to tell the truth?
Yes, I do.
Thank you. Go ahead, Ms. O'Grady, whenever you're ready.
Thank you. We're almost there. Great. Okay. Please state your name.
Charles Harvey.
Where are you employed and what is your position?
I'm a professor at the Massachusetts Institute of Technology, MIT, in Cambridge, Massachusetts.
What is your educational background?
I have a bachelor's degree in math from Oberlin College and both a master's and a PhD from the School of Earth Science at Stanford University.
Would you please summarize your work experience background?
In the late 80s, I worked for the U.S. Geological Survey, and then after graduating from Stanford, I joined the faculty at Harvard University, and then I moved to MIT, where I've had a faculty position for 27 years in the Department of Civil Environmental Engineering. I've also worked as a consultant across a variety of hydrogeologic issues. Of most relevance here, I consulted for 5 years with C12, a startup carbon capture CCS company that my former postdoc Kurt House founded in 2008. And C12 is likely the first independent CCS company, pioneered the design and unitization of CCS storage sites.
Could you summarize your research focus as it relates to subsurface flow, geologic carbon sequestration, and the behavior of carbon dioxide or CO2 plumes in saline and hydrocarbon reservoirs?
Well, my work focuses on groundwater, and it spans a range of scientific engineering and policy issues. This focus has taken me from the basic physics of porous media flow and reactor transport to geologic carbon storage, to arsenic contamination of groundwater, to groundwater seawater interaction, to the ecology of peatlands. And I have experience with both field measurements and numerical model development.
I apologize. Can you give me just 1 minute? There's an odd beep that's happening throughout the room. Is there anything we can do about it, or should we just nothing? We just have to live with it?
We may have to just live with it. It's the fire alarm.
Oh, all right. Well, I apologize for the room acoustics this morning. Thank you. Please proceed.
Of course, thank you. What research was highlighted as a key contribution leading to your recent election to the National Academy of Engineering?
My research on subsurface fluid flow and groundwater contamination.
Have you published peer-reviewed work on the physics, chemistry, behavior, and engineering of geologic carbon storage?
Yes.
Please describe your published peer-reviewed work.
I've published over 60 scientific articles across topics in hydrogeology. I've published 8 articles, including 1 editorial on carbon capture and storage. In 1 relevant science paper, we showed that conventional methods for generating ensembles of subsurface parameters do not produce preferential conduits for flow. The conventional statistical models that generate random fields don't typically allow for connected features with high permeability. And the consequence of this paper's result is that the variogram approach, as detailed in the EPA's UIC Program Class 6 well site characterization guidance, fails to generate permeability fields with the most risk of CO2 migration. I just picked out that one paper.
Is Conservation Group's Exhibit 4 an accurate copy of your resume?
Yes.
Dr. Harvey, you supplied direct and rebuttal testimony on behalf of Conservation Groups in this matter, Conservation Groups Exhibits 5 and 25, respectively?
Yes.
Is that testimony accurate to the best of your knowledge, and do you adopt it?
Yes.
In broad terms, what opinions will you provide?
Well, I will provide opinions on the division's proposed rules. Overall, my recommendations are grounded in the fact that few CCS projects have injected CO2 into deep saline aquifers, and pre-injection model predictions have proven wrong at saline aquifer facilities for which there is published data. Long-term safety of CO2 storage is a prerequisite for project success, because once an aquifer has been contaminated by CO2 mobilized metals or by brine, it is unlikely to be remediated over human timescales. This factual context demands a regulatory framework that's designed for uncertainty and failure, not one that assumes success.
Can you please explain the different zones of potential endangerment associated with an injection project and why modeling is limited in its ability to predict the extent of both zones?
Well, models are used to define two zones of endangerment, a typically larger zone of increased pressure, and then an inner zone of CO2 pure phase plume. The reservoir simulation models used to predict the extent of both zones are inherently unreliable. For example, an analysis of over 500 ExxonMobil exploration wells drilled over 2 decades found that more than 20% of the failures to find oil and gas in near field wildcats, in other words, regions with a known hydrocarbon system, were a direct result of mischaracterization of the trap and seal, meaning that even with best-in-class skill and plentiful site data, 20% of the time reservoir geologists incorrectly surmise that a cap rock would contain buoyant oil and gas. In the saline aquifer storage context, there's no production history, data is sparse, and the stakes of prediction error are higher. 20% failure rate, probably not acceptable here.
Please discuss the importance of designing enforceable protections.
Well, designing enforceable protections from the get-go will help ensure adequate enforcement is possible down the road. I'll briefly touch on where this shows up in a few different sections of the rule. 3 to be precise. First, the area of review, the AOR, defines the area where monitoring, corrective action, and seismicity coverage are placed. Defining it conservatively from the outset ensures adequate safeguards. The proposed rules define the AOR as the region surrounding the geologic sequestration site where USDW's drinking water aquifers may be endangered by the injection activity. Within this area, action thresholds must be defined before the permit is issued, because a regulatory standard without pre-specified thresholds cannot be consistently or reliably enforced. Second, safety critical decisions must be automatic rather than discretionary. The consequences of delayed action will be very difficult to remediate, and operators have economic incentives that run counter to the precautionary response. We have experience in this country of applying for Class 6 permits, but we have very little experience actually injecting large quantities of CO2 into saline aquifers for storage. Most captured CO2 and most of the 45Q tax subsidies are for enhanced oil recovery. Across the world, we have data from only a handful of CO2 storage sites that are not EOR facilities, and the results from these sites are pretty discouraging. They haven't behaved as they were predicted to. In the US, we have only one site, the Archer-Daniel Midland site in Illinois, that has actually injected much CO2. And as you know, one of their wells suffered corrosion and failure. And furthermore, the CO2 plume moved faster than originally modeled and was affected by other injection wells. And I want to give a couple quotes here from a recent paper that is my Exhibit 6, Bucher et al., 2025. So from on page 8, they conclude in their analysis of the 3D seismic data from this site that they used to image the plume. We have analyzed data from time-lapse seismic surveys at the Illinois Basin Decatur project, that's the Archer-Daniel Midlands project, and interpret that the CO2 plume migrated along major faults very soon after injection began, entering upper units of the reservoir and moving laterally in response to injection at the neighboring site. These observations emphasize the importance of considering faults as potential flow pathways, as well as the impact of pressure from neighboring injection sites on plume dynamics. And earlier on page 2, they say during the post-injection phase, well logs detected an isolated finger of CO2 in the injection well in a shallower zone than the injection interval, the origins of which could not be ascertained previously. The application of an amplitude-agnostic time shift analysis reported here reveals clear qualitative images of growing CO2 plumes in shallower intervals of the storage reservoir that arrived by migration of previously identified faults. So one important aside here is we only know about this plume behavior because of the extensive 3D seismic that they conducted. So the success of Class 6 permitting regulations cannot be judged by the number of permits issued, and we should not mistake experience in crafting permit applications and decades of CCS promotion with actual knowledge of how CCS sites perform. And in the rest of my testimony, I will avoid words like typically and usually to describe what actually could happen in the real world, because we just don't have the data to make such claims. And the third point I want to make is about scientific transparency, including disclosure of model assumptions, code validation, calibration metrics, and raw operating data. This is all essential because a regulator who can't see the data and reasoning behind a model's predictions cannot evaluate safety. For example, where CO2 injection volumes or pressures in Class 2 enhanced recovery operations create risk equivalent to a dedicated storage project, the operation must be subject to Class 6 requirements because the Class 2 framework was not designed to manage the risks of long-term CO2 storage. Of the Class 6 permit applications that I've seen, there is no way I could figure out how their modeling works. I don't know if this is because of the extensive redactions. Tens of pages are just black, kind of uses up your ink cartridges, or if it's because the regulations don't hold the applicants to meaningful standards of completeness and transparency. But the information in these applications alone is inadequate for me to understand the modeling claims that underpin their application.
Please explain the particular risks associated with long time scale of containment of injected carbon dioxide.
In short, the time horizon of regulatory protection should match the time horizon of the hazard. And we believe that stored CO2 plumes persist for centuries or millennia, and obviously we don't have any data on that. But we know that infrastructure degrades on time scales of years to decades, and water resources that are impacted, that are impractical to develop today, could become essential for New Mexico communities in the future. CO2 resistant materials must be required at all depths in wells that may encounter the CO2 plume and should not be required in the injection zone alone. Plume stabilization, the point at which the CO2 plume has ceased migrating, must be demonstrated through sustained monitoring rather than assumed from model predictions or tied to fixed calendar. The option to petition for shortened post-injection site care period before the end of injection should be eliminated.
Turning now to conservation groups' specific proposed amendments, what is the purpose of the amendment regarding confidentiality of information?
When constructing a permit application, operators necessarily rely on publicly available information to build their case for safety. This information often includes earthquake data, well locations, well completion reports, geologic maps, stratigraphic sections, and diagnostic fracture injection tests from existing wells. Claims of confidentiality for this type of information undermines the right of New Mexicans to evaluate key public information that underpins the basis for the permit and may irreversibly affect their water resources. The rights of New Mexicans shouldn't be subordinated to the claims of commercial sensitivity of geologic and other relevant data that is already in the public domain.
What is the basis for changing the triggers prompting Class 2 wells to apply for Class 6 permits?
The proposed rules require a well to transition from Class 2 to Class 6 if the primary purpose of the well shifts and there is an increased risk to USDWs. Conservation groups propose to amend this rule to require a transition if either of these circumstances exists. Class 2R wells for enhanced oil recovery should be evaluated for the duration and rate of proposed CO2 injection in the absence of oil and gas extraction. Class 2D proposal wells have not been evaluated for CO2 injection, and both cases require a comprehensive site characterization.
What is the basis for requiring consideration of the integrity of the caprock seal when determining whether there is an increased risk to underground sources of drinking water?
Well, operators should evaluate not just whether a caprock exists, but whether that caprock can maintain its sealing capacity under the fluid regimes and pressures and upward buoyancy forces to which it'll be exposed after the CO2 is injected. If an overlying caprock becomes fractured, faltered, or it's mineralogically reactive to carbonic acid, repurposing the well without comprehensive site characterization introduces a potential migration pathway for CO2 into the overlying aquifers or displaced brine.
What definitional changes do conservation groups propose relating to plume stabilization?
Conservation groups propose two changes. First, they propose to define plume stabilization. Second, they propose to amend the definition of post-injection site care to require monitoring and other actions needed following cessation of injection to ensure plume stabilization has occurred and the USDWs are not endangered. The rationale for these changes is that the CO2 plume does not stop moving after injection stops. Buoyancy forces continue to drive CO2 upward against the cap rock and to drive migration of CO2 laterally and vertically, hugging the underside of the cap rock. The pressure field also evolves as pressure dissipates outward. The proposed definition of plume stabilization as the point in time at which the injected CO2 stream or plume no longer expands captures the fact that containment cannot be confirmed at the moment injection stops. The proposed change in the definition of post-injection site care would ensure that the period of care extends at least until the plume stops expanding.
What is the basis for the proposed changes regarding interference with containment under anticipated changes in pressure associated with injection?
The proposed rules address information an operator must submit for consideration, which includes determinations that neither faults and fractures nor seismicity would interfere with containment after injection increases pressures. Conservation groups propose adding language to both provisions to require that these determinations specifically consider faults and fractures under the anticipated change in pressure associated with injection. Faults near an injection site serve both as potential migration pathways for CO2 or displaced brine, as well as potential sources of induced seismicity that can compromise the mechanical integrity of wellbores and surface infrastructure. The current regulatory framework addresses these risks through qualitative seismic history that in practice amounts to placement of a regional seismicity map in the permit narrative. That approach provides no information about how specific faults at a specific site with their geometry will respond to the sustained pore water pressure increases that large volume CO2 injection produces. EPA cites research supporting this amendment. Ultimately, whether a given fault reactivates and whether reactivation produces conductive fracture pathway or damaging seismic event depends on site-specific properties, the local stress field, fault orientation, frictional characteristics, proximity to the crystalline basement, and the magnitude and rate of pressure change. None of these parameters can be evaluated from a regional seismic catalog. However, dynamic fault stability analysis, which entails quantitative modeling of how identified faults respond to projected injection-induced pressure evolution, addresses each of these gaps. It requires the operator to characterize the in situ stress state, identify and map faults within the pressure footprint, and evaluate whether projected pressure changes are sufficient to bring these faults to failure under site-specific conditions.
Conservation groups propose a number of changes to the area of review and corrective action rules at 1915-43-9E and MAC. Starting with 1915-43-9E2B2 and MAC, what changes do conservation groups propose?
The proposed rules require that the area of review and corrective action plan, or CAP, include in a description of monitoring and operational conditions that would warrant early reevaluation of the AOR. Conservation groups propose that these conditions include pre-specified well-specific exceedance thresholds in pressure monitoring data and geochemical monitoring data, or the discovery of a previously unidentified artificial penetration. The rationale for this proposal is that the AOR is derived from a reservoir simulation model, which predicts how pressures will propagate where CO2 will migrate and at what rates. This prediction becomes useful only after it has been updated with actual data that describes how the actual CO2 plume behaves. If a pre-specified monitoring threshold is exceeded in any monitoring well, it means the model predictions have failed, and that any product derived from the model, such as the map of the AOR, is no longer dependable. At which point, the appropriate response is to recalibrate the model to match the observed data and redelineate the AOR. Making this reevaluation automatic upon threshold exceedance removes the discretion to continue operating under an AOR that the operator's own monitoring data have invalidated. And a model that can't reproduce the data it was designed to predict has no basis for predicting the boundaries within which the public is supposed to be protected. The discovery of a new artificial penetration with an AOR is material new information that changes the project's risks and must trigger reassessment. This addition is particularly warranted in New Mexico because well inventories in mature basins are often incomplete.
What is the basis for conservation groups' proposed amendments regarding independent third-party verification and use of qualified professional experts?
The AOR model is a foundational component of the Class 6 framework. If the only people who've examined the model are the people the operator paid to build it, the state is accepting a safety determination. Well, it's not independently evaluated. Moreover, research shows that even highly experienced geoscientists with decades of proprietary data have made predictions about reservoirs that contain considerable uncertainty. The delineation of the AOR requires technically specialized skills, requiring deep experience in both numerical methods and site-specific geoscience. The process involves substantial professional judgment at every stage, and these choices affect results in ways that can shift the AOR boundary by kilometers. A qualified professional requirement analogous to existing EPA standards for groundwater monitoring ensures a defensible professional standard, but even simply specifying a qualified person perform the analysis would be an improvement. As an important aside, oil companies successfully use, the fact that oil companies successfully use multi-phase models does not demonstrate that this approach is necessarily appropriate for guaranteeing Class 6 project safety. And I think there are three things that are important to understand here. First, oil companies invest vastly more resources and expertise into their models that are possible for Class 6 permit applications. Second, oil companies accept risk that's not acceptable for CO2 storage. Oil companies accept risk in production because not all oil and gas plays produce as much as modeled. But you know, a 90–80% success rate is good for them, not necessarily good for us. And third, and I think most importantly, oil companies don't apply their models to prove an outcome that they prefer. Instead, they use the models to objectively test scenarios before they make investment decisions. They want to characterize the risk as accurately as they can so they can decide where to put their money. For these reasons, all three of them, the use of the models by the oil industry doesn't mean that model results presented in Class 6 permits are as valuable for guaranteeing the storage of CO2, the safety of CO2 storage.
Can you explain why you support the provision of third-party verification of the modeling ensemble to the public?
Existing Class 6 applications to the US EPA have not made the model evaluation reasoning part of the record available for public comment, requiring instead that the public know how to request specific administrative documents and be able to do so within a very limited public comment window.
Turning to the proposed amendments to the delineation of the AOR and identification of wells requiring corrective action, What is the basis for requiring the use of peer-reviewed or commercially available modeling?
Well, predictions are only as reliable as the software that produces them. Without peer review or a model developed to a commercially available standard, neither the state nor the public can possibly determine whether the code correctly implements the physics it claims to represent. And without full disclosure of the code's assumptions, the state cannot evaluate whether the model is appropriate for the site. Requiring full disclosure of code assumptions, governing equations, equations of state, and constitutive relationships ensures that the state can evaluate whether the model is appropriate. The current rule treats AR modeling as a black box. The operator submits predictions, but the reasoning behind them is often opaque. A regulator reviewing a conclusion without access to the reasoning behind it cannot perform meaningful oversight. EPA's AR guidance already recommends each element of this amendment.
Why is a definition of the AOR based on pressure necessary?
Well, if the AR is drawn only around the CO2 plume, it may exclude legacy wells, faults, and drinking water supplies with within the larger pressure affected zone outside of this small regulatory perimeter of the CO2 plume. The pressure front can extend far from the plume itself, and within this zone of increased pressure, elevated formation pressures drive native brines upward through old wells and fractures into overlying drinking water aquifers. To take the precautionary approach to protecting New Mexico's water resources, the AOR needs to be delineated such that it is at least as large as the maximum extent of the model zone of increased pressure and the model CO2 plume extent. EPA's AOR guidance already takes this position. The regulatory language makes the recommendation of EPA a requirement. This rationale also supports the subsequent proposed provisions, which specify how the AR should be calculated.
Thank you. And as a quick time check, we're at about halfway through your time. What is the basis for the proposed amendment relating to a modeling ensemble approach when modeling the AOR?
Well, a single model run produces one prediction of pressure and CO2 migration with no indication of how wrong this prediction might be. If the single run underestimates the AOR, then legacy wells, faults, and drinking water aquifers within the actual area of influence are left unprotected. For several decades, reservoir engineers have developed a variety of statistical methods for generating ensembles of simulations that attempt to capture uncertainty. Uncertainty is clearly very important for CO2 storage. A 10% failure rate is not good. So this large body of technical expertise should not be ignored for CO2 storage.
What is the basis for requiring the carbon dioxide plume simulation include reactive transport modeling, accounting for the geochemical reactions and lithology of the target reservoir and caprock?
In certain rock types, particularly carbonate reservoirs, emitting geochemical reactions from the model will produce simulations that are wrong about where CO2 will go and how the confining formations will perform. And this is because reactions change the rock's porosity, permeability, mechanical strength over time. The EPA's AOR guidance acknowledges the need for geochemical considerations, and its site characterization guidance goes further, explicitly discussing reactive transport modeling as a tool for evaluating how, quote, reactions, e.g. loss of carbonates, precipitation of carbonates, long-term dissolution of silicates, can change permeability, release undesirable elements, alter injectivity, and affect ultimate storage capacity, end quote. In formations where carbonate minerals are present in the caprock or reservoir, the geochemical effects that reactor transport modeling captures are physical realities that will occur whether or not the model accounts for them. Making the modeling optional in such formations is equivalent to allowing the operator to ignore a potential degradation mechanism.
What is the basis for explicit regulatory delineation of an intensive corrective action area tied to the anticipated lateral extent of the carbon dioxide plume itself?
As I discussed earlier, CO2 injection creates two qualitatively different zones of threat to drinking water, and the regulators should address both. These provisions would require an operator to identify the zone that may come into contact with the CO2 plume to ensure adequate corrective action is taken in the area. The 50% buffer is warranted because multi-phase flow simulations are notoriously uncertain, and ensemble modeling consistently shows substantial uncertainty in plume boundary conditions. Furthermore, the CO2 plume can continue to migrate laterally after it escapes the injection formation. That's good. Yeah.
What is the basis for requiring 3D seismic characterization of the full AOR?
Well, faults within the AOR are pathways through which CO2 and brine can migrate from the injection zone to overlying drinking water aquifers, and induced seismicity on these faults can damage wellbore infrastructure. You cannot evaluate a fault that you haven't found, and 3D seismic is the best technology with the coverage and resolution to map faults across the full AOR.
Why should a Class 6 project account for interactions with other operational or historic injection projects?
When multiple wells inject into the same formation, their individual pressure fields combine, pushing the total area of evaluated pressure beyond what any individual wells model would predict. And with it, the area where drinking water aquifers are at risk. If each well is modeled independently, the resulting AORs will be undersized.
How would this provision account for potential interactions between Class 1 and Class 6 wells?
Class 1 hazardous waste injection wells and Class 6 CO2 storage wells frequently target the same types of deep saline formations. However, introducing a Class 6 project into a formation that already has Class 1 hazardous waste into Class 1 hazardous waste plumes superimposes a more complex and disruptive set of subsurface processes onto an existing containment system that was not designed for these conditions. Specifically, the concern is pressure interaction. CO2 injection generates pressure perturbations that propagate far beyond the CO2 plume itself. So a pre-existing Class 1 facility may find that the safety margins embedded in its containment analysis are no longer valid once a nearby Class 6 project alters the pressure field. The geochemical dimension compounds the pressure concern. If the CO2 plume or CO2 saturated brines migrate far enough to interact with the hazardous waste plume, it introduces carbonic acid into a geochemical system that the Class 1 permit may never have been evaluated for. The regulatory gap here is straightforward. Under the current framework, Class 2 and Class 6 permits are issued independently under separate regulatory programs, often by different agencies. Each permit is issued as if the other program doesn't exist. This exact risk is playing out at the MarkWest carbon injection project in Putnam County, Illinois, as discussed in greater detail in my pre-filed direct testimony. New Mexico shouldn't replicate this regulatory gap.
What is the basis for the proposal that specific predictions at a key monitoring well be used to help ensure that the carbon dioxide plume model is sufficiently accurate in its representation of plume evolution?
Okay, so this is an important proposal. Without direct observational evidence that the CO plume is going where the model says it should, the entire permit safety framework rests on an uncertain and untested hypothesis. If the plume migrates in an unexpected direction or at an unexpected rate, it may encounter legacy wells faults or confining zone weaknesses, and the corrective action plan did not address. And the consequence is undetected migration towards drinking water aquifers. If an operator cannot predict CO2 arrival at a location chosen for maximum confidence, the operator's claims about which aquifers are safe and which faults are beyond the pressure front lack credibility. Pre-injection models have failed to capture plume behavior at CCS sites. The ones for which we have data, they've almost all failed. Requiring AOR reevaluation upon prediction failure is necessary for developing a useful model.
Why do you recommend that New Mexico adopt regulation requiring Class 6 applicants to document a detailed search for artificial penetrations?
Every missed well within the AOR is a potential unmonitored, unevaluated conduit through which injection-driven pressure can push contaminated brine into a drinking water aquifer. Relying on a single database may miss wells. EPA guidance identifies state databases, county records, and private databases as necessary sources and acknowledges that detecting abandoned wells can be very challenging. This amendment codifies the multi-source search that the guidance already described as necessary.
And what is the basis for the requirement that operators field test all abandoned wells without complete plugging records?
A well for which there is no plugging record may be completely open to the injection zone, completely sealed, or anything in between. The only way to know is to go look at the well.
What is the basis for the requirement that corrective action be taken on wells determined to penetrate into the confining layer or that are located in the intensive corrective action area, in addition to other wells determined to need corrective action?
There is uncertainty in the depth of the boundaries of different layers across an AOR. And since the precise topography of the tops and bases of formations is not known without direct observations, in many shaly formations, some portions of the formation are more permeable than others. The precautionary principle dictates that a well penetrating any depth of the confining layer should be treated as a potential leakage pathway. Any well within the ICAA has a potential to come in contact with the CO2 plume, and we know that CO2 in brine is a corrosive environment for standard materials, carbon steel and Portland cement, used to construct and plug most abandoned wells in New Mexico's mature basins. Within the ICAA, where CO2-bearing brine will plausibly be present, any conventionally plugged well is therefore a potential pathway for contamination of overlying drinking water aquifers. One that may fail immediately, but will fail eventually as the cement degrades over the years to decades that it remains exposed to CO2.
What is the basis for the requirement that owners or operators use CO2-resistant materials in all components of well plugging used and at all depths?
Conventional Portland cement and carbon steel are known to degrade with exposure to CO2 mixed in brine. Conventional materials are certain to degrade, but the rate and consequences are uncertain. At ADM's Decatur facility, That's the Archer Daniel Midland site. The only facility that is injected, and it's the only facility has injected a large quantity of CO2. An EPA permitted monitoring well built under modern Class 6 requirements developed corrosion leaks within just a few years of construction. Plugging a well with CO2 resistant material at select intervals fails to address some problems. CO2 is buoyant and can migrate along the wellbore. And I think it's very useful to think about how when a narrow finger of CO2 migrates along part of a borehole, it can create enormous buoyant forces that keeps it moving upward. Any interval it reaches can become a failure point. The cost difference between CO2 resistant and conventional material is dwarfed by the magnitude of the 45Q tax credit that operators are expected to receive from the federal government.
What are the proposed amendments regarding AOR reevaluation?
There are a few proposed changes to this provision. The first change ties back to where conservation groups propose the operators confirm the model's validity by placement of a monitoring well where the plume is modeled to be after 1 year of commencement of injection. Increased pressure also endangers drinking water beyond the plume itself. If the pressure increase fails to conform to modeled expectations, then the model is not consistent with the subsurface it was supposed to represent, and the AOR it produced is no longer defensible. The basis for the other proposed triggers for AOR reevaluation have been discussed earlier in the testimony.
Turning to injection well construction requirements, what are the proposed amendments?
Monitoring wells are designed to test for increased CO2 concentrations and therefore shouldn't degrade in the presence of CO2. For this reason alone, they should be constructed throughout the wellbore with materials that have the best chance of withstanding the corrosive environment introduced by CO2 dissolved in brine.
What are the proposed amendments for testing and monitoring requirements with regards to groundwater monitoring?
The proposed rules require a groundwater monitoring plan, but they don't require that the plan specify how contamination will be statistically determined. The operator is not required to specify what constitutes the detection, what statistical test is applied, what significance level is used, or how many background samples are needed. These choices are left to the regulator's case-by-case approval of plan language that may be qualitative rather than quantitative. The result is that 2 Class 6 permits could use entirely different statistical approaches or no formal statistical approach at all, and both would be compliant. In contrast, RCRA's regulations developed over decades of hazardous waste monitoring require the operator to specify the complete quantitative framework before the permit is issued. If EPA determined that hazardous waste facilities require pre-specified statistical rigor to protect groundwater, there is no scientific basis for requiring less of CO2 storage facilities.
What are the proposed amendments regarding the number of monitoring wells?
Several Class 6 applications in other states have relied on data from a single well or on analog data from distant formations, an approach that provides little basis for evaluating whether the characterization represents the site geology. The subsurface properties that control CO2 flow may vary over short distances and cannot be inferred from measurements made elsewhere.
What is the justification for a network monitoring design that accounts for detection of maximum risk scenario simulations?
The scenarios likely to damage USDWs are precisely the ones the model underestimates or misses. Migration along an undetected fault, flow through a legacy well, the inventory mist, or pressure-driven brine displacement at the AR periphery. If monitoring wells are not placed to detect failures, the first evidence of failure may be contamination of drinking water.
What is the basis for the requirement to run additional simulations of the CO2 plume in which grid spacing is increased and decreased by a factor of 2?
Okay, this is a simple, but I think very important modification that's often overlooked. Model grid spacing is a well-known source of serious errors in models of fluid flow in the subsurface, particularly models of two-phase flow like CO2 and brine. CO2 often migrates in thin layers, thin vertical upwellings, fingering patterns that cannot be captured by large grid spacing in models. And so models that fail to predict this rapid, long-range, thin finger migration, or models fail to predict it. At the ADM site in Illinois that I talked about, the reanalysis of seismic data indicated that CO2 moved upward faster than predicted. At the Norwegian Sleipner site, esoteric models had to be employed to recreate the remarkable sequence of appearance of horizontal layers of CO2 that sort of migrated upward from the point of injection. To begin to assess whether grid spacing correctly resolves physical behavior, the modeler can try different resolutions and see if the output changes. This is a fundamental part of verifying a numerical code because the choice of grid spacing is often completely subjective, and it doesn't represent, a physical reality, and so it should not be overlooked.
What is the basis for mandating the completion of a pressure fall-off test?
As a minimum, pressure fall-off tests must be performed on site because the intent is to measure on site hydraulic parameters, and running to completion gives better information. However, a diagnostic fracture injection test, a DFIT, would be preferable because only this test can determine the maximum safe pressure for injection, the fracture pressure. Diagnostic fracture injection tests measure the fracture closure pressure and formation permeability and reservoir characteristics that directly control whether injection will exceed geomechanical limits. Substituting data from another site could be invalid.
Please explain the need for continuous monitoring at monitoring wells.
Elevated formation pressure is the primary mechanism by which CO2 injection can contaminate drinking water aquifers beyond the CO2 plume itself. If the actual pressure response exceeds what the model predicted, drinking water aquifers far from the wellhead may be at risk. Continuous pressure monitoring, even when not approaching a threshold, is the key measurement for testing and calibrating models, as demonstrated at Snøhvit Norwegian site and the Insala sites. Continuous monitoring is warranted because a gauge that records only at scheduled intervals may capture a trend but can't identify the timing of discrete pressure events that can indicate escape with the temporal resolution needed to trigger an operational response before the event progresses.
What is the basis for mandatory surface air monitoring?
Surface air monitoring provides a detection method independent of the subsurface well network and can catch CO2 releases over a larger area that may contain leaks through failed legacy wells, unknown penetrations that event directly to the surface. In areas with high legacy well density, a failed well bore venting to the surface may be detected only by atmospheric sensors.
What is the basis for requiring the use of peak ground velocity or peak ground acceleration?
Well, what damages wellbore cement shears casings, opens fractures through CO2, through which CO2 can reach drinking water aquifers, is the ground motion, not the energy released at the earthquake source. Two earthquakes with the same magnitude can produce vastly different ground shaking depending on depth, distance, local geology. Switching to one of these metrics calibrates the threshold to the actual risk of damage to the infrastructure protecting drinking water, rather than, I'll leave it there.
What is the basis for requiring periodic material compatibility recertification of monitoring well construction against CO2 corrosion knowledge?
Because CO2 injection into saline aquifers is still largely experimental, there's been only one site, the ADM site, with significant injection in the US. The science of material behavior under CO2 storage conditions is still evolving. A monitoring well built to specification considered adequate a couple of years ago may not meet current understanding of CO2 corrosion risk. And a well that is itself degrading cannot reliably monitor whether drinking water aquifers are being contaminated. Periodic recertification against current knowledge prevents the monitoring infrastructure on which drinking water protection depends from being grandfathered in under specifications that advancing science may render inadequate.
Turning to reporting requirements, what is the basis for requiring reporting of all gauge malfunctions and instrumentation failures?
For regulatory agencies to have confidence that monitoring data are complete and accurate, they have to know when data are missing, suspect, or interpolated across gaps. Even a short instrumentation failure can coincide with transient pressure excursions, a seismic event, or anomalous geochemistry whose significance only will become apparent in retrospect. Without mandatory reporting, the monitoring record presented to the regulator appears complete when it is not, and compliance determinations are made on data whose reliability is unknown. This is a data integrity issue with negligible compliance costs relative to the value of the information it provides.
What is the basis for the elimination of pre-injection cessation, post-injection site care shortening petitions, and a demonstration of at least 5 years of rigorously defined plume stabilization before such petitions are approved?
Allowing an operator to petition for shortened post-injection monitoring before injection has begun or while it's ongoing allows the most consequential long-term drinking water protection decisions to rest on a model that hasn't been tested against all of the operational data. Plume stabilization must ultimately be demonstrated through post-injection monitoring data, not assumed from model predictions. Only after a body of operational evidence has accumulated can a shortened post-injection site care petition be adequately evaluated. Restricting the timing of post-injection site care petitions is insufficient. However, if the standard the petition must meet is left vague, plume stabilization, the point at which the CO2 plume has essentially ceased migrating, is the condition under which it becomes reasonable to reduce monitoring, because a plume that stopped moving is no longer encountering new potential pathways to drinking water aquifers. Without a rigorous definition, an operator can characterize a pause in migration as stabilization, secure reduced oversight, and then face resumed plume movement that goes undetected. Requiring 5 consecutive years of demonstrated stability, as discussed earlier, with a proposed definition of plume stabilization, provides an evidentiary standard high enough to distinguish genuine stabilization from temporary equilibrium, seasonal variations, or sensor drift. Drinking water protection obligations should not be reduced until the standard is met with observed data.
In the interest of time, I'm going to skip the next question and jump to the last question. What are the proposed changes to conditions that would require immediate cessation of injection, and what are their bases?
There are a few proposed changes to this provision. First, a significant seismic event is grounds for cessation. An earthquake induced by CO2 injection can damage the wells and cement seals that prevent CO2 and brine from reaching drinking water aquifers. And once a fault has been opened as a fluid transmission pathway, the contamination risk is immediate and irreversible. Second, a statistically significant geochemical change is direct evidence that the containment system is not performing as predicted. The rational response to observed evidence of containment is to remove the driving force, injection pressure, immediately before the pathway widens or additional formations are affected, and while the operator works to establish whether the seal has indeed been breached or bypassed. Third, I've discussed the dangers associated with the release of carbon dioxide detected by surface air monitoring earlier in my testimony. Fourth, evidence of unauthorized fluid migration, specifically that CO2 or displaced brine has entered an unauthorized zone, means the containment system has failed and continued injection will only drive more fluid through the breach. Allowing discretionary resumption before remediation is complete creates a structural incentive to characterize the problem as minor and resume revenue generating injection rather than close the pathway. Fifth and finally, gauge malfunctions for longer than a week warrant injection cessation because pressure and geochemical gauges, pressure gauges at a CO2 injection facility are the only real-time indicator of whether injection is proceeding safely. Leaving the decision of when to restore instruments to operator discretion creates an economic incentive to continue injection during data gaps rather than incur the cost of shutdown.
Thank you for that summary of your direct testimony. We will now move to your summary of rebuttal testimony. Let me know when you're ready, no rush.
Yeah, so let me get myself organized here. Okay, I think I've got myself organized.
Okay, great, thank you. In broad terms, what opinions does your rebuttal testimony provide?
OCCC's proposed modifications relax the regulatory framework on which the safety of New Mexico's drinking water depends. For proposed modifications to the protections proposed by the division or by conservation groups, operator cost or convenience is a key justification rather than scientific evidence.
OCCC's witness recommends that the list of minor modifications not subject to formal permit revision procedures include non-material, non-substantive permit modifications that do not increase risk to underground sources of drinking water to prevent permitting delay. What is your response?
This catch-all category provides too much leeway to a single official without the benefit of formal and independent review. The terms in the proposed formulation, i.e. non-material, non-substantive, and does not increase risk, are subjective. They shift determination of risk to the operator and bypass public review. OCCC's witness argues that the director's ability to subject a Class 6 permit to modification, revocation, and reopening of public participation for any amendment creates significant uncertainty for project developers. However, the purpose of Class 6 permitting is to protect underground sources of drinking water, not to minimize uncertainty for developers. If a modification generally does not affect risks to underground sources of drinking water, the operator should have no difficulty demonstrating that through formal review. A modification that cannot survive public scrutiny should not bypass it.
OCCC's witness recommends that New Mexico match the frequency of area of review reevaluations to the 5-year frequency of the federal rules, as the data collection and simulations needed to reevaluate an area of review are time intensive. What is your response?
OCCC's witness grounds this argument in cost and convenience again. The commission should begin with a different premise: protection of New Mexico's drinking water aquifers. The precautionary principle demands frequent demonstrations of safety. Moreover, claims about prohibitive costs should be weighed against the substantial federal subsidies, tens of millions of dollars annually, that these projects will receive. And I want to emphasize one particular physical reason why early review is vital. And that is that the information provided by pressure data comes early and fast during injection. Pressures at the wellbore change very quickly immediately after injection begins. And then the rate of pressure change decreases roughly logarithmically with time. For this reason, the information content of pressure data is greatest early and should be acted on. If I were managing a project, I would begin work on recalibrating the model immediately after injection begins. You learn a lot right away, and I certainly would not wait for years. The ADM Decatur project in Illinois illustrates why more frequent evaluation is warranted. Within the first decade of injection and after injection of only a few million tons, pre-injection models had failed to predict actual plume behavior, and a monitoring well developed corrosion failures. If infrastructure damage and unexpected migration can occur within a few years at a well-characterized site, a 5-year reevaluation cycle is insufficient.
OCCC's witness recommends that groundwater monitoring be required annually rather than quarterly, as she claims that quarterly monitoring is an excessive burden on owners or operators that does not provide additional protection to water quality and the environment generally. What is your response?
Again, the precautionary principle instructs that the risk of damage to New Mexico's water resources requires more frequent monitoring. OCC provides no basis to support the idea that quarterly monitoring provides no additional protection over annual monitoring. Peer-reviewed literature, the EPA, and statistical reasoning contradict this position. Monitoring frequency is a fundamental component of monitoring design that determines statistical power and how quickly changes in groundwater conditions can be detected. Only one data point per year is just not enough. The RCRA regulatory framework, which also addresses management of hazardous waste, provides a helpful comparison. Given the complex hydrologic processes, strong buoyancy effects, and larger pressure footprint here, sampling frequency on par with or more rigorous than RCRA is warranted.
OCCC's witness supports the addition of gamma ray testing, but encourages the division to remove spontaneous potential as a logging method, as it provides redundant information and can increase risks to well integrity. OCCC also recommends that the list of logs and tests be made optional. What is your response?
Gamma ray resistivity, spontaneous potential, and caliper logging are all essential tools that enable characterization of a wellbore. Each tool captures different information, as discussed in my written rebuttal testimony. Eliminating spontaneous potential as a logging requirement and making other logging tools optional would weaken the regulation's ability to protect drinking water. Regarding the proposed elimination of spontaneous potential, I have a few concerns. First, spontaneous potential logging responds to salinity. Gamma ray logging is not analogous because it responds to rock mineralogy rather than the fluids in the rock. So it can't determine whether the groundwater is fresh or saline. Second, spontaneous potential is a simple sensor consisting of a single passive electrode mounted on the wireline string and is recorded passively on the same wireline descent as the same tool on the same tool string as the resistivity log that Oxy's witness proposes to retain. Since the tool is already in an open hole, I don't see any incremental risk to well integrity. I also have concerns regarding the proposal to make each logging test optional as conveyed in the language from must to may and the change from and to or. The mandatory logging suite doesn't just provide technical content. Because the required logs are specified in the rule, they become part of the permit application, which is subject to public notice and comment under Class 6 permitting processes. If an operator is permitted to propose whatever logging program it prefers, the burden shifts from the regulator to the regulator and the public to identify missing logs and argue for their inclusion during review and public comment.
Oxy's witness recommends that New Mexico decrease the frequency of review and amendment of the emergency and remedial response plans to match the 5-year frequency of the federal rules. What is your response?
The emergency and remedial response plan governs what happens when containment fails. Since operational conditions relevant to this plan, for example, ejection rate, nearby drilling activity, monitoring results, community circumstances, all change continuously, extending the plan review could render it out of date when it's needed. Instead of making review less frequent, I would recommend the plan to be made publicly available annually, shared widely, and accompanied by public hearings in the affected communities. The people whose drinking water is at risk have a right to know what steps are being taken to protect it, and they have a right to raise concerns before a crisis occurs. This public visibility would also incentivize operators to keep their plans current.
Oxy's witness recommends that in the case of evidence showing that the injected carbon dioxide stream and associated pressure front may cause an endangerment to an underground source of drinking water, the owner and operator only be required to immediately cease injection in the impacted well. What is your response?
Injection wells within the same project are usually hydraulically connected. The pressure field created by one well affects and is affected by those of others. If an operator is allowed to continue injection activities in other wells within a project, it creates an incentive for them to characterize potential endangerment as localized and continue injecting at other wells despite the risk. Requiring cessation of all injection at the project until an operator has demonstrated that the source of potential endangerment has been identified or remediated is the best way to protect New Mexico's water resources.
Thank you for the summary of your rebuttal testimony. Dr. Harvey is now available to give serve rebuttal. Should we take a quick break first?
I think that's a good idea. Let's come back at 10:45. Back from the break, please. Do we have Dr. Harvey?
Yep, I'm here.
There you are. Go ahead, Ms. O'Grady.
Perfect. All right. So, Dr. Harvey, Mr. Eels testified on Wednesday that a plume migrating outside the area of review would be unlikely to trespass on pore space belonging to other people because unexpected migration would first trigger an area of review reevaluation. Can you talk about your experience operating a CCS company and thinking about trespass issues?
Yeah, happy to. When we started the CCS company back in 2008, we considered only storage formations that had structural lateral containment in addition, obviously, to a good confining caprock. This lateral containment could be either an anticline, storing the CO2, upside down bowl, or a structural trap having to do with, geologic structure. We took this approach because lateral containment provided confidence that the bounds of lateral CO2, on the bounds of lateral CO2 migration. Buoyancy can drive thin layers of CO2 long distances along the upward sloping underside of caprocks. And we considered lateral structural confinement to be necessary to keep the plume from trespassing under property where we did not have pore space rights. And furthermore, it was the only rational way to map a unitization area. We also applied for a patent for injecting large quantities of air to test the integrity of formations. We thought that an empirical confirmation of integrity was important, and insurance companies asked for it as a means to conduct their actuarial calculations. Now, this precautionary thinking waned with shifting politics, and as it became evident that almost all 45Q subsidies would go to EOR, not geologic storage. So now flash forward 20 years, and the topic has shifted towards modeling the uncertain migration of CO2 plumes through formations without lateral containment.
Division witness Dr. Hassan Kaniani rejects conservation group's proposal to require third-party verification of the modeling ensemble at pages 6 through 7 of his rebuttal testimony, in part because public comment should already provide an opportunity for technical evaluation of the application and supporting materials. Is the information made available to the public for technical evaluation during the public comment period generally adequate for technical evaluation?
No. Dr. Kaniani states on page 7 of his rebuttal testimony that meaningful public participation is best supported by ensuring that the administrative record contains sufficient technical information to allow interested parties to independently evaluate the applicant's modeling and analysis. He goes on to say that information should include, at a minimum, the model approach, software used, geologic framework, modeling assumptions, input parameters, boundary conditions, calibration data, sensitivity and uncertain analysis, plume and pressure front projections, and area of review results. But that's exactly the problem. Permit applications generally don't disclose all this information, leaving the public in the dark about the technical details and whether the applicant's analysis was adequate. That's exactly why the rules should require either disclosure of these details or publication of third-party verification. Frankly, I've looked at some of these permit applications and they're inscrutable, even to someone like me, because so much of the information is redacted.
Similarly, Dr. Kaniani rejects the conservation group's proposal to require third-party certification of the area of review at pages 8 through 9 of his rebuttal testimony, again in part because public comment provides an opportunity for additional review. What is your response?
As with the modeling ensemble, permit applicants simply don't disclose enough information for the public to be able to independently evaluate the area of review model and conclusions. As with his response to the proposal that third-party verification be required for the modeling ensemble, Dr. Kaniani states on page 8 of his rebuttal testimony that the information in the administrative record for the purpose of not just the division and EPA's for review, but also that of third-party reviewers and the public should include the modeling approach, software use, site characterization data, geologic framework, model assumptions, input parameters, boundary conditions, calibration methodology and results, sensitivity and uncertainty analysis, plume and pressure front projections, and the resulting area of review determination. If the administrative records for these projects contained this kind of information, the public would have adequate chance to provide additional review, and we would not need to propose this rule change.
Can you describe what must be made available to the public during the public comment stage under 1915-41-8E6D?
The public can request to see both the draft permit and the application under the proposed rules.
Have you ever seen a redacted Class 6 permit?
Yes, I have.
I'm going to pull up a document on my screen. Do you recognize this document as a Class 6? Hold on, actually, I will scroll to the first page. Do you recognize this document as a Class 6 permit application, specifically the Oxy Brown Pelican application? And have you had an opportunity to review it?
Yes, I have.
I'm going to show you pages 108 through 109 of this PDF. What does figure 43 represent, and what would the redacted information have told you?
See, I think I need to see 109. Is that it?
That's 109.
Okay. Yeah, so figure 43, well, the caption says relative permeability and capillary pressure for the injection zone. Yeah, so it should, I imagine it would show relative permeability curves.
And why is that information important?
That's a key input to modeling simultaneous CO2 and water flows.
Turning to pages 113 to 114 of the PDF. Here's page 113. Here's page 114. Table 4 overlaps. What does table 4 represent, and what would the redacted information have told you?
So from the title there, I think it's a history match of a parameterized relative permeability curve, but I can't see. I'm just guessing.
And then turning to page 152 of the PDF. This page tells you what Appendix B would show you. Can you read off the highlighted paragraph?
OLCV conducted an airborne magnetic survey in May of 2023 to identify and/or confirm the location of existing artificial penetrations in the AOR. The data from the survey was analyzed and interpreted by Oxy and OLCV geophysicists. Magnetic anomalies were cross-referenced with aerial photos. drone photographic surveys, and physical site observations where necessary. See Appendix B for additional details on identifying APs.
Turning to page 182. What is this section of the document?
Madam
Oh,
Hearing
looks like-
Officer, I'm going to object here. I think this is outside the scope of Sir rebuttal here.
Is this Mr. Tucker?
Yes, sorry, this is Mr. Tucker for the record.
Oh, hello. Ms. O'Grady, would you describe, please, how this is rebuttal? Extra
Absolutely.
rebuttal, excuse me.
Absolutely. Thank you, Madam Hearing Officer. This relates to the two of the prior questions about Dr. Hassan Kaniani's testimony about what is included in typical Class 6 permits as they're made available to the public. And we just have one more question, and then we'll turn to the next line of questioning.
All right. I do remember an earlier discussion, Mr. Tucker, about what was available to the public and what would be protected as confidential information. So the objection is overruled. Go ahead, Ms. O'Grady.
Thank you. Dr. Harvey, can you say once more what you believe this section provides based on the title of this page and what it might contain?
There's appendices giving information about the area of review. And then it says it's wholly, entirely redacted.
Okay. And I'm just going to show this section here on a contact sheet so you can see the sweep of pages. And I just made it too small. There we go. What would the redacted information have Appendix B have shown you?
I don't know for sure, but presumably it would show information about where old wells could be found.
So is this portion of the application helpful to you in your review as a member of the public?
No, it's frustrating, right? Because I'd be interested in knowing that about potential pathways to the surface.
And then as an expert, would this be useful to you?
So obviously not, right? It's a lot of pages of black ink.
Thank you. Turning to the next question. Division's witness, Dr. Schnarr, claims on page 15 of his rebuttal testimony that the introduction of definitions for intensive corrective action area and plume stabilization risks creating ambiguity over how these terms relate to existing Class 6 requirements and whether they establish new regulatory thresholds, obligations, or decision criteria. What is your response?
The introduction of the terms intensive correction action and plume stabilization are intended to establish new obligations. That's why the definitions are proposed. Conservation groups proposes that the ICAA be defined as an area into which brine with supercritical carbon dioxide will potentially intrude, plus a buffer to account for modeling error. Then they propose that the ICAA be identified as a subset of the area of review. Once the ICAA has been identified, owners and operators must perform corrective action on abandoned wells in that area to ensure they're plugged at all depths and with carbon dioxide resistance in that. Conservation groups propose that plume stabilization be defined as the state when the carbon dioxide stream that has been injected into the subsurface essentially no longer expands vertically or horizontally, as demonstrated by a minimum of 5 years of monitoring data. They then propose that post-injection site care can be redefined as appropriate monitoring and other actions, including corrective action, needed following cessation of injection to ensure plume stabilization has occurred and that USDWs are not endangered. This change to the scope of the post-injection site period would apply to the relevant requirements.
Ms. Wachtman also claims at paragraph 18 of her rebuttal testimony that the 50% buffer is arbitrary. What is your response?
Well, division and industry witnesses in this proceeding agree that models carry uncertainty. Buffer around the ICAA would incorporate this inherent modeling uncertainty into the regulations.
During Commissioner Ampoma's questioning of Dr. Helm-Clark on Thursday, Dr. Helm-Clark stated that she had never seen an area of review as large or larger than 10 miles. When you look at the volumes of carbon dioxide the U.S. Department of Energy has projected will be injected in the United States, how large would areas of review have to be?
Well, the DOE, Department of Energy, says that we will need to inject from 0.5 gigaton to nearly 2 gigatons of CO2 per year. So this is a vast amount, thousands of times larger than what's currently injected at the ADM site. So depending on the basins used, if we were to inject this amount, it is certainly conceivable that over years, pressure cones from multiple injection wells would overlap, creating essentially continuous AORs spanning tens of miles or more across a whole basin.
Division witness Dr. Schnarr claims on pages 17 through 18 of his rebuttal testimony that the term qualified professional expert is vague because it does not establish what qualifications, credentials, experience, certifications, or areas of expertise would be necessary to satisfy this requirement. What is your response?
Well, as discussed in my direct testimony, sorry, just had a hiccup here. As discussed in my direct testimony, the modeling choices involved in area of review modeling are complex, subjective, and consequential enough that unqualified practitioners will make errors that put underground sources of drinking water at risk. In Class 6 applications submitted to the US EPA, it is often unclear whether a trained professional built the geologic model and associated reservoir simulation framework, for example, with the Pratt Zero Carbon Project. Even simply specifying a qualified person, which does not imply a particular certification or credential, but does imply relevant experience and knowledge, would be an improvement to the existing rule language.
Ms. Wachtman objects to the proposed AOR reevaluation frequency at paragraph 23 of her rebuttal testimony. What is your response?
Ms. Wachtman characterizes this as my proposal. It's not. It's the division's. Nonetheless, I support it. At Snøhvit, which I'm mispronouncing, that's the Norwegian word for snow white. At the Snow White Reservoir, behavior diverged from predictions within the first year of injection. If the initial reevaluation occurs after 5 years, an operator would be injecting for years under the assumption that its own monitoring data may have already been contradicted.
Ms. Wachtman justifies the longer interval between AOR reevaluations in part by saying in her rebuttal testimony at paragraph 26 that projects permitted by EPA, including Oxy's Region 6 permits, operate successfully at 5-year intervals. On Friday, Ms. Wachtman testified that Oxy does not yet have operational projects. Are Oxy's pre-operational projects evidence that the 5-year reevaluation interval is appropriate?
No, and Oxy's experience with EOR projects isn't really relevant. First, oil reservoirs are not net injections. They remove oil and gas in larger quantities than they cumulatively remove more oil and gas than they inject CO2. So they're typically underpressured, not overpressured. Second, in an oil reservoir, they can manage movement of the CO2 plume through extraction from oil and gas wells, which pulls the CO2 towards those wells. And third, data from oil fields is not public. So there's no way for the rest of us to assess any claims based on that.
Division and OCC witnesses object to conservation groups' proposed AOR reevaluation triggers. Ms. Wachtman claims at paragraph 27 of her rebuttal testimony that these triggers ignore site-specific variability and that they are arbitrary and too rigid. Dr. Kaniani similarly objects on page 9 of his rebuttal testimony that fixed statewide numerical thresholds may not be appropriate given differences between projects. What is your response?
I agree that the specific numerical values should be site-specific, but the non-negotiable principle is that thresholds must be pre-specified and automatic, because without pre-specification, the question of whether an anomaly warrants reevaluation becomes discretionary judgment made after the data are in hand, when the economic consequences of acting are known. This is precisely the problem RCRA's rules were designed to prevent.
Mr. Eels testified on Wednesday that it would be very rare for a plume to move outside an AOR, as AORs are regularly reevaluated. Could a plume move beyond an AOR within a 1 to 2 year period?
Well, first of all, how do we know it's rare? We haven't done the experiments, and I don't see any reason why a plume could not be moved beyond a modeled AOR in a year or two.
Dr. Schnarr objects on page 16 of his rebuttal testimony to the proposed requirement that operators use peer-reviewed or commercially available modeling codes. Specifically, he claims that such a requirement would be overly prescriptive and would attempt to codify detailed technical methodologies better addressed through permit review, guidance, and project-specific evaluation. What is your response?
Conservation group's proposal would not require the use of any particular software package. It simply requires code that has been independently scrutinized. A code that has never been peer-reviewed or commercially validated fails to give the regulator or the public basis to trust whether it correctly implements the physics.
OCC and division witnesses object to the proposed requirement that there be a minimum of 4 monitoring wells. Dr. Schnarr objects on page 27 of his rebuttal testimony that this requirement would be overly prescriptive and may result in unnecessary costs for some projects while being insufficient for others. Ms. Wachtman claims at paragraph 34 of her rebuttal testimony that the number is arbitrary. What is your response?
Well, a performance-based framework without a numerical floor is indistinguishable really from no requirement when the performance objective is never quantified. 4 wells provides a modicum of a floor. The plume, say, could move in any 4 cardinal directions as well as up or down. So having at least 4 wells increases monitoring reliability. If a project requires more, they can install more. Importantly, this requirement would set a floor, so there's no risk of there being an insufficient number of monitoring wells based on this requirement. If a project requires, yeah, I'm done.
Dr. Schnarr also objects on page 27 of his rebuttal testimony to the placement of monitoring wells based on specific modeling scenarios as overly prescriptive. What is your response?
At the ADM site, unexpected migration was initially missed by monitoring design for the expected plume trajectory. This is exactly the outcome that placement informed by worst case scenarios is designed to prevent. The requirement is not to prescribe a specific location, but to ensure the monitoring network is designed to detect the scenarios that matter most, not just the optimistic ones.
Mr. Eels objects on page 9 of his rebuttal testimony to the use of peak ground velocity or peak ground acceleration as unnecessarily prescriptive. Ms. Walkman acknowledges at paragraph 48 of her rebuttal testimony that these are valid metrics, but objects to them as not being the only defensible approaches. What is your response?
What damages wellbore cement, opens leakage pathways is ground motion at the location of the wellbore, not energy released at the source of the seismic event. Magnitude-based threshold can miss the damaging event while triggering on a distant event, which is why one academic paper developed a PGV based traffic light protocol specifically for managing induced seismicity at injection sites. I had a little bit of experience with this when I was in San Francisco during the Loma Prieta earthquake. Some of you may remember one particular neighborhood in San Francisco was devastated while the neighborhoods around it weren't. The reason was that there was a lot more ground motion because of the geology of that neighborhood. If the commission believes that requiring use of peak ground velocity or peak ground acceleration is unnecessarily prescriptive, an alternate phrasing of this requirement could be that the seismic threshold metric must use peak groundwater velocity, peak groundwater acceleration, or other comparable metric approved by the division.
Ms. Walkman testified on Friday that a plume can be modeled without the use of 3D seismic surveying. How else would you model a plume if not with 3D seismic surveying? And what are some of the risks associated with these methods?
Well, one way she suggested is with geochemical methods to map out the plume using geochemical data. Now, to do that, you would need a lot, probably hundreds of penetrations taking water samples in the injection formation. But OCC themselves has argued against putting monitoring wells in the injection zone. She also suggested an operator could use a variety of other geophysical methods, but she didn't specify any in particular, and I'm not aware of one that could do what 3D seismic does. Finally, she mentioned the use of 2D seismic monitoring, but to image the plume with 2D seismic monitoring, you would need a sequence of 2D profiles sufficient to capture the 3D shape of the plume. And at that point, you've basically done 3D seismic imaging. Yeah, I'll leave it there.
What do you think about the idea of putting monitoring wells into the injection zone?
Well, I think it should give us pause when someone argues that the injection zone is so corrosive and unstable that it is dangerous to make direct measurements of it. But yes, you need monitoring wells to measure the pressure in the injection zone. 3D seismic can monitor the plume movement over time, although it still misses features of CO2. So you could conceivably verify the CO2 plume model with 3D seismic data taken over time instead of a monitoring well. But you still need a set of metrics ahead of time, specifically arrival time at specific spots to verify the model.
Ms. Walkman objects at paragraph 50 of her rebuttal testimony to mandatory DFIT tests because technology evolves, she argues, mandating a specific methodology is contrary to sound regulatory practice. What is your response?
DFIT test is advisable and should be conducted because right now it's the feasible way to measure the maximum safe pressure of injection. Clearly, the maximum safe injection pressure is a key, if not the key, to safe injection. And the DFIT is the way to measure it.
Ms. Wachtman objects at paragraph 54 of her rebuttal testimony to the proposed requirement that operators report all gauge malfunctions and instrumentation failures within 30 days, as she claims routine instrumentation issues don't indicate mechanical integrity loss or USDW endangerment. Mr. Eels objects to this proposal on pages 9 through 10 of his rebuttal testimony because the term malfunction is not defined and could encompass minor operational issues. What is your response?
Ms. Walkman is correct. Gauge malfunctions and instrumentation failure don't indicate mechanical integrity loss or drinking water endangerment. Rather, when they fail, what it indicates, or what we know, is that we've lost information. So this is a data integrity requirement, and even a momentary or short instrumentation failure could coincide with transient pressure excursions. On the subject of definition of malfunction, it could be defined as when no data is being produced or the data is physically implausible. And I'd be fine with adding to the definition sections to refine this.
Ms. Wachtman objects at paragraphs 59 to 60 of her rebuttal testimony to the proposals requiring 24-hour reporting and shutdown for gauge malfunctions exceeding 1 week. Her rationale is that this would generate immaterial notifications and lead to unnecessary shutdowns. What is your response?
Madam
It's
Hearing
just
Officer.
I'm sorry?
Madam Hearing Officer, this is Aaron Tucker. My understanding from the pre-hearing order was that Sir rebuttal would be limited. We've now approaching about 30 minutes of Sir rebuttal, more than the time allocated for rebuttal. How long are we, can I get a ruling on how long we're providing for Sir rebuttal here?
Yeah, I know we discussed the rebuttal, and I think I described my approach to it, which is so long as it is genuinely Sir rebuttal and not just a repetition of earlier testimony, that I thought it was appropriate. Let me ask Ms. O'Grady, though. Ms. O'Grady, how much longer do you believe you have?
I would suspect 10 minutes, but I did not anticipate that there would be a time limit on Sir rebuttal.
Right, I did not impose one. Thank you for the question, Mr. Tucker. I have been listening carefully, and so far it has been Sir rebuttal. She's very specifically reading the rebuttal to which it is Sir rebutting.
Right,
But thank you.
Thank you, Madam Hearing Officer. Dr. Harvey, the question was about gauge malfunctions. Please proceed.
Well, I lost the question. I'm sorry. What did you ask?
No worries. Ms. Wachtman objects at paragraphs 59 to 60 of her rebuttal testimony that the proposal requiring 24-hour reporting and shutdown for gauge malfunctions exceeding 1 week. Her rationale is that this would generate immaterial notifications and lead to unnecessary shutdowns. What is your response?
Well, as discussed just a bit ago, the concern with gauge malfunction is that during the window a gauge is malfunctioning, operators and regulators lack visibility into threats. Ms. Wachtman's characterization of this requirement as capturing every gauge anomaly is I think, an overstatement. This simply places a 1-week threshold on how long an operator may inject without functioning monitoring equipment.
Mr. Eels objects at page 11 of his rebuttal testimony to the proposed additional circumstances that would trigger a pause and cessation. He claims they are unnecessarily prescriptive because they limit the flexibility needed to respond to the site-specific conditions that may arise during operations and also infringe on the director's discretion. What is your response?
The automatic triggers establish a floor. The director's discretion to act beyond the floor is preserved. At Insala, the operator voluntarily decided to halt injection when monitoring revealed dangerously high fluid pressures and land surface deformations. This was a discretionary operational decision. A different operator faced with different economic pressures might not have made the same choice, which is why pre-specified triggers change discretionary safety decisions into automatic ones.
Commissioner Chosky asked a question on Wednesday about surface air leaks, and Mr. Eels testified that a surface air leak would trigger cessation of injection under 1915 43-9I-6 NMAC. That portion of the rule specifies that an owner or operator must cease injections when a well demonstrates mechanical integrity issues. If a surface air leak occurred due to a leak along a fault rather than an injection well, would that trigger cessation of injection? And would a cessation of injection under this provision trigger implementation of the emergency remedial response plan? And finally, sorry, compound questions, but can you please discuss the prevalence and form of leaks at natural gas storage sites in the United States?
So first, I think, of course, any surface leak should trigger a cessation of injection in the emergency and remedial response plan. And yes, a leak is not, I think, not through a well, not necessarily through a well, but could be through a fault or fracture. Perhaps the best data we have for surface leaks are actually our experiences at natural gas storage leaks that leak methane, another buoyant gas. These are analogs to CO2 storage sites. I know the British Geological Survey tabulated 9 leaks through geologic features, not wells, a lot more through wells to the surface. I think I'll leave it there.
Thank you. Ms. Wachtman testified on Friday that one eddy flux tower would not even cover a well pad, let alone a larger area, and would thus be impractical for larger projects. Can you discuss the function and utility of eddy flux towers?
Yeah, I'm happy to, because I'm working with eddy flux or eddy covariance towers in my research on wetlands, both CO2 and methane fluxes. Now, back when I was at the CCS company, we were researching the use of eddy flux towers to monitor CO2 leakage from carbon storage sites. Back then, federal subsidies were low, and we were focused on CCS as a means of reducing greenhouse gas emissions. Now the interest is more in harvesting federal subsidies, and oil companies are driving much of it. So this is a tool that doesn't come out of petroleum engineering. But because we're interested in reducing carbon dioxide fluxes to the atmosphere, eddy flux towers are natural. They measure over very large areas, and they measure the flux, not the concentrations like soil gas measurements. So they measure what you're looking for, CO2 escaping, rather than having to infer the actual flux or escape, infer flux or escape from just measured concentrations. And yes, an eddy flux tower easily covers an area much larger than a well pad.
Dr. Schnarr objects on pages 25 through 26 of his rebuttal testimony to the proposed groundwater monitoring design and statistical methods requirements as overly prescriptive, overly detailed for regulatory text, and potentially inappropriate for some projects. What is your response?
Well, I think in some circumstances, regulations need to be prescriptive to be effective. That's why RCRA's groundwater monitoring requirements, which were developed over decades of hazardous waste monitoring experience, required each of these elements to be specified before the permit issues. This is because EPA learned that leaving the statistical framework to case-by-case discretion was vulnerable to post hoc selection of methods that minimize the appearance of contamination. CO2 storage presents monitoring challenges at least as complex as hazardous waste disposal.
Relatedly, on Wednesday morning, Dr. Schnarr discussed the role of guidance, specifically the fact that guidance is not binding on an operator. In the afternoon, he also stated that guidance offers additional flexibility that rules do not. Do you think safety guardrails should be mandatory?
Yeah, I think safety guardrails are necessary.
Dr. Kaniani objects on pages 9 to 10 of his testimony that reservoir simulation models are not inherently unreliable, but are instead developed using broad site-specific data and refined through an ongoing model monitor update process. Uncertainty, he claims, does not mean unsuitability. What is your response?
Well, ongoing, the word that Dr. Kaniani uses, suggests that when you get data conflicting with your model, you redo it right away. I would support that approach because that's the approach that's taken when models are expected to accurately predict reality. Uncertainty in reservoir model prediction is well known. Dr. Kaniani states as much, acknowledging that reservoir simulation models contain some level of uncertainty because subsurface conditions cannot be measured directly at every location. Where we disagree is what that uncertainty demands of the regulatory framework. In petroleum engineering, model error costs the operator money. The operator adjusts and continues, but certainly doesn't wait years. In Class 6 permitting, model error could mean that drinking water aquifers within the actual zone of endangerment receive no monitoring or corrective action. And that mistakes are only discovered after contamination.
Dr. Schnarr objects on page 16 of his rebuttal testimony to the proposal that operators provide with their permit application information about the fault leakage and induced seismicity under anticipated changes in pressure associated with injection. He claims that this information is unnecessary because the existing rule already requires characterization of known or suspected faults and fractures as part of site characterization and area of review modeling, which will consider project-specific pressure. What is your response?
Characterization identifies where faults are, but dynamic stability analysis determines whether injection-induced pressure changes will cause them to slip. Whether or not they will slip is key to whether they can maintain, whether containment of injected CO2 can be maintained. To my knowledge, permit applications typically do not perform dynamic fault stability analysis.
Ms. Wachtman testified on Friday in response to a question from Welk's counsel about Oxy's proposals at 19-15-43-903A that if multiple wells were impacted, they would have to stop injecting. However, she expanded on this testimony in response to a question from Commissioner Ampoma about the same provision, that two wells in the same area of review could be experiencing different conditions, and that if there was no evidence of mechanical integrity issues in one of the injecting wells, there would be no reason to stop injecting. What is your response?
Yes, if one well has mechanical integrity issues, it's true that you wouldn't need to stop injection in the other wells unless they were in danger of leaking. But I'm not sure that's exactly the issue here. If there is a risk to the USDW, then yes, multiple wells that are impacting the USDW would need to be shut down.
Mr. Eels agrees on page 14 of his rebuttal testimony with Oxy witness Ms. Wachtman that a 5-year review of the emergency and remedial response plan is reasonable because there shouldn't be significant changes in the plan that would necessitate an earlier review. What is your response?
The 3-year review cycle is the division's proposal. Conservation groups support this proposal.
This ends Dr. Harvey's testimony. We now move to admit Exhibits 1 through 26 into the record.
I'll pause for a moment in the event there are objections to the admission of Exhibits 1 through 26. Right, they're admitted. Thank you.
Dr. Harvey now stands for cross-examination and questions by the commission. Thank you.
All right, thank you. Mr. Chair, how would you feel about an earlier lunch break?
That's just fine by me.
All righty, let's come back at 12:30.